Good afternoon everyone. Myself Pandram from Government First Grade College Bidar. My PowerPoint presentation is Atomic Absorption and Emission Spectroscopy. So I am going to deal with about the atomic absorption and emission spectroscopies, introduction, principle, theory, instrumentation and working, operations of atomic absorption and emission spectroscopy, interferences, applications, comparison between both the techniques, advantages of atomic absorption over atomic emission spectroscopy, and conclusion. So first, atomic absorption and emission spectroscopy, both are the type of atomic spectroscopies. So the atomic spectroscopy is based on the either absorption or emission of light by an atom. So on the basis of their absorption and emission, atomic spectroscopy are broadly categorized into three categories. One is atomic absorption spectroscopy, atomic emission spectroscopy, and atomic fluorescence spectroscopy. So I am going to deal with the atomic absorption and emission spectroscopy. Coming to atomic absorption spectroscopy, it is the elemental analysis techniques which are used to determine the concentration of element present in the given sample solution. So this techniques is mainly applied for the determination of concentration of metal present in the sample solution. So this technique also used for both qualitative as well as quantitative elemental analysis. This is relatively simple and reliable technique which use the absorption of electromagnetic radiation in order to determine the concentration of elements. Next one is in order to understand what is atomic absorption spectroscopy, first we have to know some of the theoretical background and their history. So in the year of 1672, Sir Isaac Newton studied the spectrum of sun by using the prism. So this is the representation of Isaac Newton, which he used the prism to disperse the light. Later in the year of 1802, Wollaston discovered the black lines present in the spectrum, but he failed to explain the origin of these black lines. Later in the year of 1807, Fraunhofer studied this line and assigned the letter A for the strongest lines which is starting from the red end of the spectrum, and these lines we called as Fraunhofer lines. Next in 1820, Brewster explained these black lines. So the main application the analytical application of atomic absorption spectroscopy was discovered by Alan Watts. So this is the Alan Watts representative, who is the scientist in CSIR Melbourne, Australia, and he is known as father of atomic absorption spectroscopy. Next one is the principle of atomic absorption spectroscopy. The general principle involves first the liquid sample solution is converted into the droplets. This is called as nebulization. Then when it is introduced into the flame, the solvent is evaporated by leaving a solid residue. This is called as dissolution. Then this solid residue is converted into the free gaseous atom, which is absorb the electromagnetic radiation and get excited. This absorption measured in atomic absorption spectroscopy. Next is theory of atomic absorption spectroscopy. So before understanding the process, first we have to know the structure of the atom and their electronic transition. So the atom consists of a central core which consists of the neutron and the proton and electron revolving in different orbitals having different energy. So the electron normally present in the ground state. This is lower energy state. When any absorb its electromagnetic radiation, it gets excited from ground to excited state. So this excitation is depend upon the energy supplied between the two energy state. So this is the electron get jumped from ground state to excited state by absorbing the energy. So next, this is represented by delta E is equals to E2 minus E1, which is equals to H nu, and the total absorption is given by nu equals to pi E square mc into NF. Next one is instrumentation of atomic absorption spectrophotometer. There are two types of instrumentation are employed. One is a single beam atomic absorption spectrophotometer. Another one is double beam atomic absorption spectrophotometer. This is the general representation of single beam atomic absorption spectrophotometer. This consists of the radiation source, atomizer, monochromator, detector, amplifier, and recorder. Next one is the components of atomic absorption spectrophotometer. This consists of radiation source. There are various kind of radiation sources are used, but mainly hollow cathode lamp and electrode discharge lamp is employed. This is the general representation of hollow cathode lamp. This consists of a hollow cathode in which the element of interest is placed, which has to be determined in the given sample solution. Then the tungsten wire is inserted, which is acted as an anode, and the tube is filled with the ionizing gases, which is such as neon or argon. So these ionization gases, when the potential difference is applied, they get ionized and strikes with this element of strength, which gives the emission spectrum which passes through the flame. Next one is electro discharge lamp. This is another radiation source which are used for the element which are volatile in nature. So this is the general representation of the electro discharge lamp. Next one is atomizer. So atomizer is a device which are used to convert the liquid sample solution into the fine droplets. So this is the procedure of the atomization of liquid into the free atoms. There are two type of atomizers are used. One is flame atomizer, another one is electrothermal atomizer. The flame atomizer solely depends upon the flame. So the flame used in atomic absorption spectroscopy have a eligible temperature which is more than 2000 Kelvin. So some of the flames which are used in atomic absorption spectroscopy are given in the table. Next one is the structure of the flame. So every location of the flame having the different temperature, which consists of three regions. One is primary reaction zone, secondary reaction zone, and interconal zone. So in atomic absorption and emission spectroscopy, we use the interconal zone. This is the hottest region in which the liquid sample is converted into the free atoms. Next one is types of burner. So there are two types of burner used in atomic absorption spectrophotometer: total consumption and pre-mixed or laminar flow burner. In total consumption burner, the fuel, oxidant and sample are introduced in different paths, which is lit at the base of the flame where the atomization takes place. And in pre-mixed burner, same, the sample and oxidant are passes through the different paths, and then nebulizing gases are passes which speed up the reaction of the sample. Next one is electrothermal atomization, which is another type of atomization which consists of the in which the electricity is passes through the body. So this is the general representation of the graphite atomizer. Next one is nebulization. So the nebulization is the process of conversion of liquid into droplets. The common method of nebulization is by using a moving gas at a higher velocity, which is called as pneumatic nebulization. Next one is the monochromator. There are two types of monochromators are used. One, generally the prism is employed for a particular element. The grating also used. Next one is the detector. So in detector, the photomultiplier tube is used, which consists of photocathode and number of electrodes, which is known as the diodes. Next is amplifier, which used to amplify the electronic signal obtained from the detector and read out device read the spectrum. Next is working of atomic absorption spectrophotometer, in which already we discussed about how the emission spectrum coming from the hollow cathode. This emitted light passes through the chopper. Then in flame, the free atoms are present which observe the particular radiation from this radiation source and get excited. This absorption light is passes through the monochromator, which disperse and slit select this particular wavelength of radiation which passes through the detector, where the multiplication of electron takes place, which convert this electronic signal, which amplifies and readout device detect this absorption signal. Next, this is another one representation, the double beam atomic absorption spectrophotometer, to increase the sensitivity of the signal. So in this case, the signal obtained from the hollow cathode are chopped into two different radiation. One is passes through the slit, another one is passes through the flame, which are recombined to give the correct signal of the atomic absorption spectrophotometer. Next one is operation. So the operation of atomic absorption spectrophotometer are based on the two methods. One is calibration curve method, another one is standard addition method. In calibration curve is the simple plot of absorption versus the concentration of unknown elements. So this is the general representation of calibration curve. Next one is the standard addition techniques. In standard addition technique, there are 2 to 3 samples are prepared, in which the standard element of known concentration is added, and then the graph is plotted as blank addition versus the standard addition, and concentration is determined. Next one is interferences. So the interferences arises due to the overlapping of the our analyte element signal with that of the other element present in the sample solution. So on the basis of that, there are 4 types of interferences encountered. One is spectral, chemical interference, ionization, and matrix of physical interferences. So the spectral interferences arises due to overlapping of signal obtained from our element and the different element present in our sample. So for the general example is when the iron signal is overlap with the cadmium, so this can be represented. So method of overcoming is by using the collision set to destroy this signal, or suppression of analytic by using the extraction technique. Next one is application of atomic absorption. Next one is sensitivity and detection limit of atomic absorption spectroscopy. The atomic absorption spectroscopy are not used to detect all the elements present in the nature. It is detectable only fewer elements. So the pink colored element are used to determine the atomic absorption
Why?
spectroscopy.
What about others is not same?
Because of the ionization energy of these elements are very high, which is really not possible to ionize by using these radiation sources. Next is application. This is the general important topic of any atomic or instrumental method. First one in qualitative analysis. So when the atomic absorption spectrophotometer is introduced, the qualitative analysis is started, which is due to determine the particular element in the sample solution. Next one is the quantitative analysis. It is the principal application of atomic absorption spectrophotometer used to determine the concentration, which is based on the calibration curve or standard addition technique. Next is determination of lead in petrol. So there are two types of anti-locking agent, tetraethyl and tetramethyl, which are used to determine by using atomic absorption spectrophotometer. Next application in food industry used to determine lead, cadmium, arsenic in the tea leaves using graphite atomic absorption spectrophotometer. And second one is analysis of lead and cadmium in rice and some of the micronutrients such as calcium present in the milk. Next, in case of forensic, it is used to determine the criminal sample from blood, body fluid and their brain, which is used to determine in forensic. And in clinical application, it has various applications to determine the potassium, magnesium in the blood sample, and also used to determine the sodium, potassium in brain fluid. In pharmaceutical also it has various applications. Some of these are used to determine the active pharmaceutical ingredients, shelf life of the drugs and stability of the medicine. Next one is atomic emission spectroscopy. This is also type of atomic absorption spectroscopy.
Next.
Atomic emission spectroscopy is based on the measurement of emission of light by an atom. So this is the general representation when the atom absorbs the electromagnetic radiation, get excited while coming to a ground state, emit radiation. This is measured. Next principle. So general principle involved in atomic absorption spectroscopy same as that of the emission, in which the absorption is measured, here the emission of the light is measured.
Next.
The instrumentation. So the general instrumentation is same, only the difference in the radiation source. Here the radiation source is not used. Next is the atomizer, and various components used in atomic absorption spectrophotometer is same, only the different radiation source, and it is solely depends upon the temperature of the flame. Next is working of atomic absorption spectroscopy, atomic emission spectroscopy, in which the sample is aspirated into the flame where the free atoms is present, in which the signal is passes through the lens. Some of the signal are passes through the concave mirror, which reflect this towards here, and monochromatic disperse select the particular wavelength of the radiation and passes through the detector, which amplified and carried out the field. Next, application of atomic absorption spectroscopy. It is used in qualitative analysis as well as in quantitative analysis for the measurement of concentration of element. It is particularly used for group 1 and group 2 element. Next one in for agricultural field. It is used for the determination of potassium in the soil, potassium in the inorganic fertilizer, as well as potassium in the plant. In pharmaceutical, it is used to barium, calcium and sodium. Next, in food industry, it is used to determine the concentration of sodium in the junk food and minerals, milk minerals by using flame photometrically. In environment also, it has wide application to study the dissolved solid present in the water and potassium present in the soil sample. From the atomic absorption and emission spectroscopic survey analysis, I concluded that both this atomic absorption and emission spectroscopy has wide application in various fields, for including in case of agricultural field, forensic field, biochemistry, as well as in case of environmental science. Although they have application in various fields, some of the drawbacks also there of both the techniques. So in case of atomic absorption spectroscopy, the radiation source consists of only one element at a time and determine only one element. So this is also a drawback. In flame emission spectroscopy, these techniques purely depend upon the temperature of the flame. So sometimes this is also a drawback of atomic absorption spectroscopy.
Any limitations of AS?
Yes, there are many limitations of AS, which depends upon the radiation source, in which only one atom is placed, one element is placed, and at a time only one element is determined. So many elements cannot be determined from the AS.
Okay, we are using two instruments, AS and AS. What are the difference?
Radiation source. In case of AS, we use the radiation source, hollow cathode lab. In case of atomic emission spectroscopy, flame itself acts as the excitation source.
Okay, you have done very well, and you have put so much of efforts to prepare a project report. Okay, if sir, any question both of you ask that one.
What are the sources you have consulted for preparing this presentation?
Oh, so there are a
In
lot
any
of.
journals,
You-
online, yeah, like this. Okay.
Sir is NAC director. Yes.
So I refer many of the sources from.
Science Direct also, you refer some journals from Science Direct, na?
Yes, sir.
Okay.
Science directly. So many books I
Okay.
No, the thing is that you should be specific while answering, isn't it? So many books means so many books should be included in the references.
Yes, sir.
Correct? Eh?
I like particular.
So, whatever the books, you give the science director,
Yes, sir. The fundamental
Journal
chemistry,
of-
analytical chemistry by Smoke.
that is the book, whether you refer this paper number 5.
Yes, sir. Yes, sir. I refer, sir.
Where?
And from this I have taken the applications of in the food industries.
Likewise, so because
After you have to highlight.
so you should be the specific. So many books you cannot say. Correct? So these are some of the things.
Okay. How
This
to
is the
feel?
training.
Sir,
And that improves the purpose of doing this project presentation is that you should get little bit knowledge in detail as well as how to present, how to write. It gives you some type of the stage daring and how to explain the same thing, how to face the audience, and it helps you in whenever you are going for the interview to present the board of appointments and all and discussion. That is the purpose. We are asking you people or the student to present your project. Project work or whatever it may be the thing. Okay?
you tell me.
Okay. Take
You tell me your opinion about this topic and how we gain knowledge or not gain, that type of things. Your experience you tell.
Okay. By making the literature survey on the literature survey on the atomic absorption and emission spectroscopy, I feel that how to make the notes and how to take the content from the next. I learned so many things from that, and how to make the PowerPoint presentation, how to make the stage career. So that all the things I learned. Also, in case of I am going to interview in various pharmaceutical industry after completion of masters. So I have the stage career now, and I am confident about this topic. So I can thoroughly explain these topics in various interview. So this is the thing that I want to thank you Siddhartha sir for their tremendous work.
Sauban sir also.
No, it's okay. Okay, he is the chairman and
Okay.
okay, thank you.
Thank you very much.
Okay, sir.